Hello, ladies and gentlemen. This is Miss Stratton again. So we're going to be Hello, ladies and gentlemen. This is Miss Stratton again. We are going to be moving on to our second lesson in this little series on matter. Today, we're going to be focusing on elements. So go ahead and title your Cornell Notes Elements Notes, and don't forget to add your LEQ. Your LEQ for this set of notes is what is an element and what makes elements different from each other. So first of all, what makes up an element? An element, first of all, is a substance composed of a single kind of atom. A hydrogen atom is not the same as a helium atom. A helium atom is not the same as a magnesium atom. These are all different, and we're going to look at what makes them different as we move on. So first of all, each element is identified by its atomic number, and the atomic number is equal to the number of protons. We talked in our last set of notes about how a proton is a positive subatomic particle that lives in the nucleus. And so that's what we're counting to determine our atomic number. So the example we have here is chlorine. Chlorine has 17 protons. Therefore, that is the atomic number of chlorine. For our purposes right now, that is the same number of electrons. This is assuming our particles are not charged. Charged particles are called ions, and we may get to those later on. But for our purposes now, we have the same number of protons and electrons. Next, so what is the periodic table? The periodic table is the tool that we use to organize our elements. So at the very top, you will see the name of the element. You know, that's pretty important. The atomic number, which we just said is the number of protons. The chemical symbol. Now, the chemical symbol is always going to start with a capital letter. It's typically going to be 1 or 2 letters, sometimes even 3 with some of our synthetic elements. Those are the man-made elements. So the first letter will always be capitalized. Anything after the first letter will be lowercase. And that's just so we can tell when new elements start. They always start with a capital letter. And last but not least, we have the atomic mass. That is an average of the masses of the naturally occurring isotopes. Now, an isotope is an element that has different number of neutrons. So chlorine is going to have between 35 and 36 protons and neutrons in the nucleus. So that average is going to work out to an atomic mass of 35.45. That doesn't mean we have pieces of parts of neutrons. That just means this is the average mass. It's going to be between 35 and 36. Now, this is the periodic table. It was created by Dmitry Mendeleev, and it was arranged by the elements according to their atomic numbers. There were lots of different models that he came up with first and lots of other people came up with. This is just the one we stuck with. And as we learn more about the periodic table, we will see that each column has similar properties, and we'll talk more about those in a later video. But right now, you just need to know that each of these columns share some characteristics. Now, we talked about what these things mean, and now we're going to talk about how we can use the periodic table or each block in the periodic table to figure out the number of protons, neutrons, and electrons in each of our elements. So here we know that chlorine has an atomic number of 17, which means it has 17 protons. The atomic mass is going to be, the atomic mass is the total number of protons plus neutrons. It's, like I said, it's an average. And we're going to round this. So this will be rounded down to 35. So you're going to do the atomic mass minus the atomic number to figure out the number of neutrons, and the number of electrons will be equal to the atomic number. Let's work out a couple of these together. This one's pretty simple. So hydrogen has an atomic number of 1, and atomic mass of 1. So we have 1 proton. Let me get my little pen guy here. So we have 1 proton. So if we subtract the mass from the atomic number, we're going to get 0 because 1 minus 1 is 0. And then we know that we have the same number of electrons as we do protons. So we have 1 proton, 0 neutrons, and 1 electron. So we work through that one together. And now we are going to go to the next slide. I'm going to erase this first. So. All right. So next element we are going to look at is going to be oxygen. Oxygen has an atomic number of 8, an atomic mass of 15.99, which we'll round up to 16. So we know that if we have an atomic number of 8, that we have 8 protons. Now, in order to find the number of neutrons, we are going to subtract the the atomic number from the mass. So 16 minus 8 is going to be 8. And then the number of electrons is equal to the number of protons, so that is also 8. This one is pretty neat, having all numbers the same across, but that's not always going to be what happens. So let's go to our next slide. Ooh. There's got to be a better way to do this, but here's what we're doing. All right, so now we are looking at iron. Iron is not going to be quite as neat as the previous two. So iron has 26 protons because we know that it has an atomic number of 26. So we're going to go ahead and write that down. And that's not very neat, but it'll work. And so we're going to have the same number of electrons, 26. Then we're going to subtract the mass minus the atomic number, which is going to give us 30 because we're going to round 55.84 up to 56, which will give us 30. All right, guys, so now we're going to move on to our next slide, which is going to be nitrogen. Why don't you go ahead and work this one out on your own, and then we'll do it together. Do 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 do. All right, so you've had a couple seconds to work that one out. So let's look at it together. So we have an atomic number of 7, which means we're going to have 7 protons and also 7 electrons. The atomic mass on this one's pretty nice and neat. It is exactly 14. So we know that we can take the atomic mass and subtract the atomic number. So 14 minus 7 is going to be 7. All right.